Hi, I'm Fida, a third semester BSc Maths student from the Content Development Center of Majlis Arts and Science College, Valancheri. Welcome to the section. In this section, we are going to discuss about the 6 hyperbolic functions and their definition, and going to study about the graph of these functions, and also going to study about the identities of these functions. We know that there are 6 trigonometric functions. In the same way, we can define 6 hyperbolic functions also. So that first of all, consider these two figures. In the first figure, you can see a uniform flexible cable suspended between two poles, and this shape is known as catenary. And in the second figure, it is a trajectory path of a missile, and this shape is known as pursuit curve. To study about all this figure, we use a combination of exponential function. And this combination of exponential function is of the form e raised to minus cx and e raised to cx, where c is a constant. And this application is used in many fields of mathematics, and this is known as hyperbolic functions. Now we can define 6 types of hyperbolic functions. First one is sin h of x is equal to e raised to x minus e raised to minus x by 2. And cos h of x is equal to e raised to x plus e raised to minus x by 2. Here, e raised to x and e raised to minus x are defined for all the real numbers. So, the domain of sin hx and cos hx is also set of all real numbers. Now, we can define tan h of x. Tan h of x can be defined from the sin h of x and cos h of x. That is, tan h of x is equal to sin h of x by cos h of x. Then other 3 are the reciprocals of these 3 functions. That is, cosec hx is equal to 1 by sin hx, where x is not equal to 0. Here we can see that x is not equal to 0. It is because when we give the sin h of 0, we will get the value 0. Then we will get cosec hx as 1 by 0, which is not defined. So, cosec hx is equal to 1 by sin h, where x is not equal to 0. Then sec hx is equal to 1 by cos hx, and also cot hx is equal to cos hx by sin hx, where x is not equal to 0. Now we can discuss the graph of these functions. First of all, consider the graph of y is equal to sin hx. We know that sin hx is equal to the sum of 1 by 2 into e raised to x and 1 minus 1 by 2 into e raised to x. So, the graph of y is equal to sin hx can be drawn by first sketching the graph of y is equal to 1 by 2 e raised to x and y is equal to minus 1 by 2 e raised to x, and then adding the y coordinates, we get the graph of y is equal to sin hx. Here the domain is minus infinity to infinity, and the range is also minus infinity to infinity. Similarly, the graph of y is equal to cos h can be drawn by first sketching the graph of y is equal to 1 by 2 e raised to x and y is equal to 1 by 2 e raised to minus x, and then adding this, and you can plot the graph of y is equal to cos hx. Here the domain is minus infinity to infinity. You can see here the graph is always positive. So, the range is equal to closed interval 1 to infinity. Here y is equal to tan hx is equal to sin hx by cos hx. This graph can be drawn by dividing the sin hx by cos hx, then we will get the graph of tan hx. Here the domain is minus infinity to infinity, and the range is open interval minus 1 to 1. Here the next graph is y is equal to cot hx, which is equal to the reciprocal of tan hx. Here you can see that the graph is of 2 branches. This is because x is not defined for 0. So, the domain is minus infinity to infinity except in the case of x, and the range is minus infinity to minus 1 union 1 to infinity. The next graph is y is equal to cosec hx, which is the reciprocal of sin hx. Here it is also, we can see that there are 2 branches because x is not defined for 0. So, the domain is minus infinity to 0 union 0 to infinity, and the range is minus infinity to 0 union 0 to infinity. Then the next graph is y is equal to sec hx, which is the reciprocal of cosec hx. And here you can see that the graph is always positive. So the range is open interval 0 to closed interval 1. In this figures you can see that the difference between all the graphs and all the graph is defined in these two figures. Now we can study about the hyperbolic identities. The first identity is sin h of minus x is equal to minus sin h x. Here the proof is sin h of minus x is equal to e raised to minus x minus e raised to x by 2. If we put the minus outside, we get the equation as minus sin h of x. Then the second equation is cos h of minus x is equal to cos h x. From the equation it is clear that if we give any negative value for x, we get cos h x is always positive. So this proof is cos h of minus x is equal to e raised to minus x plus e raised to x by 2, which is the equation of cos h of x. Then the third identity is cos h square minus sin h square is equal to 1. We know the trigonometric identity sin square x plus cos square x is equal to 1. So the proof of this identity is if we give the values for cos h and sin h, we get the equation as 1 by 4 into 4 e raised to x into e raised to minus x, which is equal to 1. Then the next identity is sin h square x is equal to 1 minus tan h square x. This can be proved by taking the identity that is cos h square minus sin h square is equal to 1 and dividing the whole equation with cos h square x, we get 1 minus tan h square x is equal to sec h square x. The next identity is cot h square x minus 1 is equal to cosec h square x. This can also be defined by taking the identity that is cos h square x minus sin h square is equal to 1 and dividing this whole expression with sin h square x, we get the equation cot h square x minus 1 is equal to cosec h square x. Now the next identity is sin h of x plus y is equal to sin h x cos x y plus cos h x sin h y. The sixth identity is sin h of x plus y is equal to sin h x cos h y plus cos h x sin h y. To prove this equation, we are taking the RHS side and giving all the values of this function. Then we will get the equation as e raised to x plus y minus e raised to minus x plus y by 2. This equation is in the form of e raised to x minus e raised to minus x by 2, which is equal to sin h x. But here in the place of x, we have x plus y. So this equation is equal to sin h of x plus y. This is all about my section. I hope you understood the section. Thank you.